Welcome to this lecture on measuring voltage and current with a multimeter. Now, the previous tutorial we had a look at the breadboard. Before that we had a look at using the multimeter to measure resistance. We're kind of going to put those two together so we can measure the voltage across components and the current going through each of these circuits. Now first of all, have a look at this. We've got a 5 volt power supply and two 15k resistors. I've actually built that down here. My power supply connection is positive up the top, negative down the bottom. And if you recall from the lecture on the breadboard, all of this bottom row is connected together, so therefore all of that bottom row is connected to negative. All of this top row is connected together, so this top row is connected to positive. The first circuit I've got is this one. It's got a 15k resistor in series with 15k. The second circuit has a 9 volt power supply, and then we've got 3 resistors, 1, 2, 3 in series. The last one has a 10 volt power supply, and then 1, 2, 3, 4, 5 1k resistors in series. Now you'll notice that I've got all of these values, well yes, you're going to have to fill in the values, RT, IT, VR1 and so forth. So I recommend downloading the PDF version of this from your resources, pull out a calculator, do the calculations, and then you can compare them to what I actually measure in the circuit. Now one last thing before we get started. This here is the red lead of my multimeter. This one here, nope, not that one. This one here is the black lead. So I'll move them around the schematic diagram to show you where I'm actually connecting these. So let's get started. Let's first check that our leads are all good. So ohm setting, short the leads together, should come up just less than 1 ohm. So 0.1, 0.2, that's fine. Second thing, measuring voltage, DC volts, so we've got these 2 dashed lines, and making sure that our black lead is in COM, red lead is in the volts ohms connection. Now, the way I'm going to connect these to measure the voltage is red lead up the top, black lead down the bottom. So black lead to negative, red lead to positive. Let's see what we get. So that's 9 volts. I'm just going to go over here to my variable power supply. I'm going to decrease that because we need 5. Getting close. Okay, that's pretty good. 5.0 something is certainly as close as we need to get. Now, next thing we want to do is, what about the voltage of R1? Well, if you've done the calculations, you would have found that RT would be about 30k. You do 5 volts divided by 30k to get the total current, and then you can multiply that current by the 15k resistors to get the voltage. Now, hopefully you'll notice that because in a series circuit we have the same amount of current in each component, and the resistance is the same, they should have the same voltage. In this case we've got 2.5, and down the bottom here, 2.5 as well. Now remember, we have a 5% tolerance on these, so that could be off just by a tiny bit, but as you'll see, they're very much the same. Put the two together, we get 5 volts. So here's how we're measuring R1. Here's how we're measuring R2. We put the two together to get the total, 5 volts. So back on the computer screen, R1, red lead up the top of R1, black lead down the bottom. To get R2, we just put it straight across like that. Now the one thing we haven't done here is current. How do we actually measure the current in the circuit? Now you'll recall that current actually flows in the circuit. We start from the negative, it comes down, up through that component, down across here to there. So in order to measure that, we have to put our multimeter set to an ammeter in series. So we have to open circuit somewhere. I'm just going to do there. The black lead will now connect to there. The red lead will connect to there. So follow this through. We've got the electrons coming down here. They now must go up into the multimeter where we can measure it, out of the multimeter, back into the circuit, around here to the positive. So all of the electrons are now also going through here, so we can start to figure out how fast they're moving, which gives us our current flow. So to do that, we've got our 2 leads. I'm going to set this to microamps because if you've done the calculation, you know it's going to come up as a microamp value. And then this, even though this doesn't have a microamp connection, this works for both microamps and milliamps. So I've put it into that one. Now, going back to the computer screen, we need to open up the circuit. So I'm just going to disconnect R2 from the negative of the power supply, and I'll just put it somewhere by itself. Now I'm going to complete that circuit again with my multimeter. Looking back on the computer, we've got the negative, the black lead going to the negative of the power supply, the red lead going just below R2. This completes the circuit, and we're getting 168.3 microamps. Now we could put it to the milliamp setting, but we don't get as good as accuracy is not as good. It's just telling us 0.16 milliamps, so that's why we have it on microamps. Alright, so there we go. We've measured the current, and remember it could be off slightly from our calculation due to the tolerances of the resistors. What about the next circuit? So this time, I recommend get your calculator, do the calculations for RT, IT, VR1 and so forth. But the first thing that we want to do once you've done that is measure the voltage. We need to set it to 9 volts. So red lead to positive, black lead to negative, and we have to fix this up. Red lead to volts, and set it to DC volts over here. Now black lead to negative, red lead to positive, and there's our 5 volts. I'm going to go over here to my power supply, increase that to 9. Nearly there. Alright, that's looking good. So straight across my second circuit, we should have 9 volts. That's good. Let's have a look at the voltage of, let's start with R3 this time. So black lead down there, red lead there. Remember, they all have the same amount of current, but they're all different values of resistors. Therefore, they'll have a different amount of voltage each. Since the 18K is 18 times bigger than the 1K, and then even bigger than the 150 compared to the 1K, this one will get the vast majority of that 9 volts. So what do we get across this one? So nearly 8.5 volts, 8.46 volts. Alright, what do we get for R2? So remember, R2 is tiny compared to R3, so it should get a tiny amount of voltage. In fact, it is 70 millivolts, so it's way, way, way less than even 1 volt. What about R1? Oops. So R1, we put that there, that there. Now this should get somewhere in between 8.4 volts and the 70 millivolts. And in this case, it's just less than half a volt, or just less than 500 millivolts, and it's sitting around about 470 millivolts. So if we get the, 8.4 plus the 70 millivolts here, plus the, what's this one, 470 millivolts, all of that put together gives you 9 volts. And because this is an auto-ranging multimeter, so I just have to wait the proper amount of time for it to set itself properly. So hopefully I didn't go across those too quick. Okay, what about current in the circuit? Well, last time I disconnected this part here to put the meter in series with it to measure current, but just to show you that it doesn't matter where you do it, I'll connect it here instead. So black lead is going to go there. So bring that up a bit if I can. There we go. Oh, selecting the wrong thing. There. Okay, I'm just going to leave that. That's fine. And red lead there. So follow with me. The current, we start from the negative, come down here, up through the 18K, out into the black lead, through the multimeter, out of the multimeter red lead, back into the circuit. So all of the current that was flowing in that circuit is now also flowing through the meter, so we can actually measure it. So, a couple of things to set this up. Here's our leads. Microamps again, because if you've done the calculations, you'll see that the answer has come up in the microamp region. This goes into the milliamp socket. Now, where have I opened it? So you'll notice it's between the bottom of R2, the top of R3. So, there's the bottom of R2, there's the top of R3. Let's disconnect that. So now they're separated from one another. And now we need to complete the circuit with our meter. So black lead to the top of R3 3, red lead to the bottom of R2, just as the computer screen shows, 473.6 microamps. Again, that should be very comparable to what you came up with your calculation. However, with a 5% tolerance, the measured value could be a tiny bit off what you calculated. Okay, last one. So again, if you've got your calculator, work out the total resistance, total current, and then the voltage of each of these. Now again, just like the first circuit, every resistor value is the same. Since the amount of current flowing through each is the same, their voltage will all be the same. What will the voltage be? Well, if there's 10 volts total, which we need to set up here first. So I'm just going to adjust this on my power supply here. Yep, overshot there. That'll be good, just over 10. If there's 10 volts total and there's 5 equal value of resistors, we just divide the 10 up by 5. So we get 2, and then 2, and then 2, 2, and I'm sure you've guessed it, 2. 2, 2, 2, 2, 2 gives you 10. But for this particular circuit, I wanted to actually discuss a little bit more measuring voltage with respect to some other point in the circuit. So for example, if I was to ask you, what is the voltage at point, let's just put this up, I got this, there we go. What is the voltage at A compared to the voltage at B? Let's start with an easy one. Now when I say the voltage at A, I'm talking about red lead going to point A, black lead going to earth, which is the negative. So at point A, I've got 10 volts. And then when I say what is the voltage at B, I'm saying what is the voltage at point B compared to earth, which is 8 volts. So therefore, when I mix the two together, when I say, well, what is the voltage at A with reference to B, I'm saying put the red lead at A, which I know is 10 compared to ground, and then I'm going to put the black lead at B. So 8 volts is now my reference. The difference between 10 and 8 is 2. So VAB equals 2 volts. Alright, let's do a different one. What if we said, what is the voltage at C with reference to E? Well, let's first look at C. The voltage at C is 3 resistors up, 1, 2, 3. So there's point C. The voltage at C is 6, because when I say the voltage at C, I mean at point C with reference to earth down here. And then I want to know, well, what is the voltage at E? Well, E is 1 resistor up here, 2 volts. So now when I'm saying, well, what is the voltage at C, which is sitting at 6 compared to earth, with reference to E, which is sitting at 2 with respect to earth, the difference between 6 and 2 is 4. So every time I say, what is the voltage here with respect to here, I'm basically saying, what is the voltage here, take away the voltage here. And I can do it anywhere in the circuit, and it'll give me the actual answer. Okay, what about if I said, let's just make things backwards here. Let's go D with the red lead. So D is sitting at 4 volts with respect to earth. And then I put this one up at A. A is sitting at 10 volts with respect to earth. So now I'm saying, what is the voltage at D? 4. Take away the voltage at A, which is 10. So where am I putting that? So voltage at D is 1, 2 resistors up. We know that is 4 volts compared to there. And this time our reference point is going to be right up here at a positive 10 volts. As you can see here, with respect to earth, it is positive 10. So if I was to do 4, take away my reference, which is 10, it comes up as negative 6. So the reason it's negative is because my reference point, the black lead, is at a voltage that is more positive than my measuring point. So notice it doesn't matter which way around I do that measurement, it's always going to give me 6, but the only thing that changes is that you'll either get a positive 6 or a negative 6. It will be positive if the positive lead is connected to somewhere that is more positive, like that. It'll be a negative if the positive lead is connected somewhere more negative. Alright, so that's all for this one. So I know maybe look through this lecture again because quite a lot was covered. Go do the quiz and see how you go with the questions. Thanks for watching, guys.